All right, so here's our recap, okay? F of C is undefined because when you're dividing by 0, you need to investigate whether there's a whole or an asymptote, right? If you get F of C and you have and you're dividing by 0, okay, there's two possibilities, right? It's either a whole or a vertical asymptote. We said that a number divided by 0 meant that there was a vertical asymptote there. But if you get 0 over 0, it may be a whole, but you need to factor out and see if it is, right? So you have to factor needed to factor and cancel and investigate further, right? If you canceled it completely out and you got a number over a number or like 0 over a number, that's still 0, right? That's fine. But if you factor and cancel and then get a number divided by 0, it's actually a vertical asymptote in disguise. All right, so let's look at our example here, okay? Factor this rational function, and then we want to identify and classify the discontinuities, right? So if I factor this, okay, the top factors and the bottom factors. Boy, I didn't leave myself enough space here, did I? X and X. This has to be plus 3 and minus 1 here. X squared minus 1 is one you should recognize. This is where it's X plus 1 and X minus 1. Okay? And if you notice here, you've got two of the same factor going on right here, right? So if we're looking for discontinuities, we need to find out when we're dividing by 0. Okay, there's two different places here when we're dividing by 0. X equals -1 and X equals 1. Okay, those are the two different places. And as you can see, there's two different things happening there. When I try and plug in g of -1, I get a number divided by 0, right? G of -1 would be +1, -2, -3. What is that? -4 over 0. Okay, but when I plug in g of 1, I get 0 over 0, right? 1 plus 2 minus 3, 1 minus 1. So I get 0 over 0. So those are the two different issues right here, right? Because I get a number divided by 0, we know there's a vertical asymptote. At x equals -1, there's a vertical asymptote. Okay? At x equals 1, I believe there's a whole. So when I look over here and I cancel those out completely, now when I try and plug it in, factor and cancel, now g of 1 I can plug in there, oops, and I get 1 plus 3 is 4, 1 plus 1 is 2, so I get 2. So I get a number here now. When I factored and canceled, it completely went away, and now I just get a number. So there's a whole at 1, 2. The x value is here, the y value is right there, okay? So I've got two different ones here. I've got a vertical asymptote for one of them, and I've got a whole at the other one, the two different kinds of discontinuities. The vertical asymptote is a vertical line. This is the vertical line of that asymptote, and a whole is a point, so I want to make sure I give both the x and y coordinates. Let's try another one. We want to factor this one. Okay. X. I think this is +4 and -2. Yeah, you might want to try these, factor these yourself. XX. Okay, so how about 5 and 2? -5 and +2. Oh, so if you had accidentally factored this wrong, you might have gotten those two, x minus 2 and plus 2, you might have accidentally gotten those to be the same, but they shouldn't be in this case. What's happening here is I'm trying to trick you, because you got to be careful about whether it's plus or minus in that factoring. You really got to know how to factor. That's kind of an important thing to be able to do. So our discontinuities here, the two different places on bottom, x equals 5 and x equals -2, I've got two pieces here, but neither of them would be a 0 over 0. They would both be a number divided by 0. Okay, so since the factor only happens on the bottom, it doesn't happen on bottom and top, k of 5 would be a number divided by 0, and k of -2 would also be a number divided by 0. Okay, so that means both of those are vertical asymptotes. Vertical asymptote at x equals 5, vertical asymptote at x equals -2. All right. So both of these will end up being vertical asymptotes, but you have to be careful when you're factoring. You have to make sure that your factoring is correct. Otherwise, you may get things wrong and drastically wrong at that.